Welcome to 4.1, page 5. Now, if this section is feeling like, hey, there's a lot of problems here, it's kind of busy work, that's okay. You still get a point a page for these. So just pad your grade with it. The reason I'm doing so many problems in this section is, as I've said on every one of the pages so far, we cannot afford to be pretty good at this. We have to be just absolutely rock solid, efficient, quick, and accurate on these. So here we go. Find, if possible, the complement and supplement of angles. For some of you, you're 2 years removed from talking about complementary angles, supplementary angles. And this kind of, to me, speaks a little bit about obtuse angles and acute angles. And I always needed some kind of little mnemonic or some kind of little analogy to figure these things out and not forget these. So we got acute angles, we got obtuse angles. Which are the big ones, which are the small ones? And I always think, we don't usually think of like cute dinosaur, magnificent, big things are, we don't really typically think of cute. We think of cute little bunny rabbits, cute little things. So acute angles are small, and we tend to complement cute things. Complementary angles is the small. Deals with the smaller angles. It takes two acute angles to be complements of one another. So complementary angles add up to 90 degrees. Supplementary, a supplemental vitamin gives you more than what you might need. 180 degrees they add up to. So when these are degrees, this is this simple. So we're going to answer complement first and acute. So 90 degrees minus 129. Whoops. Oh, we can't have a complementary angle. Doesn't exist. That's why they say if possible. So we're not going to deal with negative angles when we're talking about complements and supplements. But supplementary, 180 degrees minus 129 degrees is 51 degrees. 87 degrees though, 90 degrees minus 87 degrees, 3 degrees, 180 degrees minus 87 degrees, 113, oh my gosh, not even close, 93 degrees, that was silly. Now, 3/4 pi, well, here's 90 degrees for complements, but that is pi on 2. Here's 180 degrees for supplements, but that is pi. So same thing here, but I need pi on 2 minus 3/4 pi. Can't do it. Not without getting negatives. But pi minus 3/4 pi, 4/4 minus 3/4 is 1/4 pi. Pi on 2 minus pi on 6, that's 3/6 pi minus 1/6 pi. That is 2/6 pi, or pi on 3. For pi, for the supplement, pi minus pi on 6, that's 6/6 minus 1/6, 5/6 pi. 12/5, pi on 2 minus 12/5 pi, can't do it, and pi minus 12/5 pi, that's 5/5 minus 12/5, doesn't have a supplement either. So pretty quick section for us. The radian measure of a central angle of a circle R that intercepts an arc of length S. We're to find that. We're to find the radian measure. So here we have a radius R. Find the radian measure of the central angle. So we've got that intercepts an arc of length S. So we've got a radius of 22. We've got an arc length of just 10. And here's where you can go formula, or you can understand the definition of a radian. A radian is the measure of an angle that in this case would create an arc length of 22. There's 1 radian. This is less than 1 radian. This is just a fraction of a radian. What fraction of the radian is it? 10 20-seconds. It's 10, but it needs to be 22. So the answer is 10 on 22, or 5/11ths. Now you can go back and base it on formula, but I'm going to encourage you to understand what radians are. So there we have it. We have a radius of 80, an arc length of 160, so there's about an 80, there's about another 80. So we're way beyond. This is an 80, that's an 80. That's 2 of these radians. It's 160 divided by 80. Now remember this one. I'm going to give you another way of understanding it, not having to memorize a formula. An arc length is a fraction of the circumference, 2 pi r. What fraction is it? Well, if I introduce theta, call this theta right here. It's theta out of, don't put 360, put 2 pi. The 2 pi's cancel. And therefore, S equals theta r, or r equals S divided by theta, or theta equals S divided by r. Just quick one-step algebra. Solve this for r, divide theta. Solve this for theta, divide r. And therefore, we take the arc to find theta, we take the arc length S divided by the radius r. So let's work to understand math. I can't tell you how happy you'll be to pay that price down the road versus those who are like, no, I'm just going to memorize. I do this and this and this. You don't understand anything. You're just a trained algebra chimp. Let's understand math. Find the length of an arc on a circle of radius r intercepted by a central angle. So let's go through that again. An arc length is a fraction of the circumference, 2 pi r. What fraction is it? If that's theta, it's theta out of 2 pi. Cancel the 2 pi's, S equals theta r. Find the length of the arc. Oh, good. We want to use this. The length of the arc is theta times r. I don't even have to make an algebra adjustment with that. R is 9. Theta is pi on 3, and we get, reduces to 3, we just get 3 pi. S equals theta. Now, notice up here, this is a biggie, we're in radian measure. This is a radian measure formula, and all of those up there are radian measures. So I can't use 135 degrees. I need to convert that to radians. I want to cancel degrees, introduce radians. These reduce by 45. That is 3/4 pi. That's what I want to use here. So arc length equals theta 3/4 pi times radius 12. 12, I'm going to make sure that pi doesn't look like it's in the denominator. That reduces to 3. 12 divided by 4, 3. We get 9 pi radians. Okay, and another fairly quick page. If it feels like busy work, I'm not even going to apologize for it in this section. We're going to master this section.